Hello everyone and welcome to our 8th video in the Intro to Programming section. In this video we're going to cover pointers, we're going to cover pass by pointer and pass by reference. So the first thing that is important that we need to cover is how to get the address of a variable and what is the address of a variable. So every variable has a value and an address. So it's important to note that we can see on the right here, so we create a number that is of type integer, and then it has a value stored, and it also stores an address. The address is not given by the user. The computer automatically generates it and is assigning it. And we notice that it starts with a 0x. That just means hexadecimal. Hexadecimal is different than base 10 numbering, which is simple 0 to 9. Hexadecimal has 16 available characters, so that's 0 to 9 plus lowercase a, b, c, d, e, f. So that's our example of how hexadecimal works. And that's how the address is stored to call its value. So we have int number 1 that equals the value of 100. So if I were to see out number 1, it's going to print the value, which is 100. But if I were to do see out ampersand number 1, it's going to go print out the address of number 1. So it's going to print out this address instead of printing out the value. So a pointer is a variable that points to another variable. It is represented by an asterisk before the variable name that tells us this is a pointer. And in order to get a value, the value of which it points to, you must dereference the pointer. So we'll walk through that. So we have int number 1 equals 100. So that's int number 1 up here, holds the value of 100 and has its own address. And then I'm creating a pointer. I create a pointer by creating a variable with an asterisk in front of it. And I have to point it to the same type. The pointer has to be of the same type of which the variable is pointing to. So if I'm creating an int pointer, then it can only point to an integer. So now I'm telling the address of number 1 to be assigned to, because it's right to left, of pointer. So I'm taking this address of number 1 and I'm putting it in the value portion of pointer. So if I were to see out pointer, that's seeing out the value, and the value in this case is the address of the number 1, so it's going to print out that address. If I were to see out ampersand pointer, it's going to print out its own address, and if I were to dereference the pointer, then it's going to print out, so dereferencing the pointer, it's going to point to this location, and then dereferencing is referring to the value in which it stores. So by dereferencing the pointer, I'm retrieving the value of 100, even though that is not the item I'm calling. I'm calling pointer, but it's going and displaying the value stored in number 1 because it points to that variable. More examples of pointers. So again, this is the same block of code that we had before. So int number 1 equals 100, creating a pointer, pointing the pointer to point to the address of number 1. Cout pointer displays the address of number 1. Cout ampersand pointer is going to print out the address of pointer, and then dereferencing the pointer is going to print out the value of which it stores. Now here I'm assigning the value of 101 to the dereference of pointer. So that's down here. So we have our pointer which points here. Dereferencing refers to this value here, and now I'm overwriting. So I'm giving it the value of 101. So now when I see out pointer, again it's just going to see out the address of which it points to. Ampersand pointer is going to print out its own address, and then the dereference of pointer is now going to print out 101. Now if I also were to go and see out number 1, we're going to notice that it actually did change the value that was stored inside number 1. So by editing it with the dereference of the pointer, it actually edits the actual variable. Next we're going to talk about a pass by pointer. To pass a pointer into a function, you need to use the asterisk in the function definition. That's referring to this location. This location right here. When passing a parameter, you can treat it like it's a regular variable, and that's referring to this location right here. And the user can modify the values, and this would change the value stored in the base variable, and this modification can be done at any location. So let's talk a little bit more. So we have our int number 1 equals the value of 100, and then I'm creating a pointer and assigning it to the address of number 1. So creating the pointer, it points to the address of number 1. And then I'm calling an add function. So the add function is just taking the first parameter, the second parameter being number 1 and pointer, and then over here it's picking it up as int first var, so I changed the variable names because that's a pass by copy. so we want to use different naming conventions. And then after that, I'm passing in an int pointer. So we're noticing that here it has to be labeled as a pointer. And in the first line of code, I'm reassigning. So I'm taking the value of 1 and I'm putting it in the dereference of the var pointer. So var pointer points to address. By doing that, I'm changing this value to the value of number 1. And then I'm adding it together. So var1, which holds the number 1, plus the dereference of var pointer, which also holds the value of number 1. So 1 plus 1 equals 2. This add function would return 2. Next, I'm going to cout number 1. Cout number 1 does not hold the value of 100 anymore because that got changed here, so that will cout the value of 1. Next is a pass by reference. To pass by reference, you need to put an ampersand in the function definition, and when passing as a parameter, you can treat it like it's a regular variable. The user can modify the values, and this would change the value stored in the base variable, and this can be done at any location. So we have our int main, we have number 1 equals 6, number 2 equals 20. Now I'm calling a modify function, passing in the 2 parameters, so number 1 and number 2. Now, this is where we notice something for the first time. I am utilizing the same naming convention. So number 1 here is number 1 here, number 2 is number 2. And the reason why I'm utilizing the same naming convention is because pass by reference actually passes the variable itself. It does not make a copy of it. So in this function, all I'm doing is I'm modifying both values. So I'm just taking number 1, I'm reassigning it to 9, taking number 2, reassigning it to 11, and then coming back here and then printing out number 1 and number 2. So this is a great example of what a pass by reference is used for. I'm passing in 2 variables, and I'm passing in the actual variables instead of making copies of them. So by passing in these variables, or by taking these variables and passing them by reference, that's recognized here by these ampersands. By passing it by reference, I can modify these, and it will actually be modified in my main. So passing by reference does not make a copy. What that means is I'm passing in the actual values to the function. It's passing in the actual variable, so if you modify the value in the function, it changes the real value. It's good practice to use the same names for variables when passing, since it's literally the same variable. So again, I always like to use the same exact variables whenever I'm passing something into a function. Whenever I'm passing by reference, I use the same exact variables. If I'm ever passing by value, I use different variable names to represent that these are 2 different items and this is 1 item altogether. So again, this is how individuals can go and get help, so please reach out if you need it. So now we're going to create a file. So we'll call it a pointer ref finish. And then I'm going to create a source file. We'll call it just pointer ref.cpp. Now, first thing I want to do is I want to include the input output it's comments. Include the input output library. After that, we can let's make some function calls. So let's create functions for pass by pointer, and then functions for pass by reference. And then let's do, after that we can get into our int main. So in our int main is used to begin the program. Within our int main, let's create 2 variables. Grab input from user, and then let's assign pointer to variable, and then let's display the variable to the user, and then from here let's make our function calls. Display the variables to the user. sorry about that, lost my train of thought. Display the variable to the user. Now let's make our function calls. So function call for pointer, and then function call for reference, and then return the value of 0 to end the program. Yeah, sorry, riddle be theirs. So include IOStream, and then we're going to be using namespace standard. And then let's create some functions. So I want to have int return type. We'll just do an add. So int var1, and then I'm passing in a pointer as the second parameter. So that'll be pointer ptr. And then we'll come back to define that. So our first is going to be an add. Our next, let's make it a multiply. Oh, sorry, wrong location. Make it a multiply, and then let's create other functions in our pass by reference functions. We'll call it ref add 1, and this is going to be pass by reference. So I want to come back to this once we get into our int main. But so we have an add1 function. Now let's do a times 5 function, and then we'll do a squared function. Cool. Now we're in our int main. Awesome. Now let's take all this and let's put it inside of our int main. Now let's create two variables. So int var1, and I'm actually only going to create one for now. And then grab input from user, cout, enter variable. And my spelling is not on point today. And then cin from the user, and that's going to go into var1. And now we want to assign the pointer to a variable. So let's create a pointer, int pointer, and let's assign it to the address of var1. Now let's display it back to the user. So cout pointer, that's going to give us an address. This is going to give us an address. Cout dereference pointer, and this is going to give us a variable. If I can spell pointer correctly, it will. Make the function calls. Let's do them in a cout statement. Cout, and it's just add. I'm passing in var1, and then I'm passing in pointer, and then cout multiply, passing in var1, passing in pointer. Because I like my spacing, I'll put that there. And I'm also a fan of the indel. Oops. Now let's make our function calls for the reference. So in this, I'm making it a void return type. So because I'm making a void return type, I'm not going to put it in any cout statements. I am just simply going to make the function calls itself. So ref add 1, and what am I passing in? var1, and then ref times 5, passing in var1, and then lastly is ref squared, passing in var1. Cool. And then we always want to return 0. Okay. So let's see where we. Okay, now let's get into our definitions. Now I'm going to change this so it's not. I'm going to call it variable 1. It's important that the naming convention is different because this I'm passing in by value. So because I'm passing by value, I want to use two different names. Now let's just have it return variable 1 plus the dereference of PTR, and then I'm going to do the same thing here, return variable 1 times dereference of PTR. So multiplying them, now I'm adding 1 to it, so I'm going to do var 1 plus, or equals, var 1 plus 1, because all I'm doing is I'm taking it and I'm adding the value of 1. So this whole segment right here takes it and adds 1 to the variable, and then all of this is being assigned to the new var 1. And then we're doing the same thing here, var 1 equals var 1 times 5. And then lastly, we're squaring it, so that's just var 1 equals var 1 times var 1. So timesing an item by itself is squaring it. So I think we're okay to test this. Now let's just let's add a line of code here. This is just going to be cout var variable, or var 1, before the reference calls. Oops. And go, and then I'll copy this, and I'll paste it, copy, paste it, and this is going to be after the reference calls. Oh, sorry, I need to definitely put the variable in there. Okay. Oh, I've done it. Alright, so I think we should be good. So let's walk through this. Save it, and then I'll let it build as I walk through it. So using namespace standard, including our libraries, of course, and then we have our function definitions. This time I didn't use prototypes. I just put everything all at the top. So we have an add function, so it's taking a pass by value and a pass by pointer, and it's passing it in. And then all I'm doing is I'm just adding the two variables. So I'm adding variable plus the dereference of pointer. Keep in mind the dereference of pointer points to variable 1. So I'm essentially adding the same variable. So if I were to pass in 5, it's going to be doing 5 plus 5 equals 10. Same thing here. I'm multiplying the same thing. So this is, you could think of this one also as a squared. So if I were to pass in 5, it's going to be 5 times 5. So it's going to return 25 back to the user. And then these are our functions, and I'm passing it in by reference. So I'm not making a copy, I'm passing in the actual variable. So any modification made, because it's a pass by reference, any modification made here will be reflective in our actual var 1 that we're holding. That's why we did, we're printing var 1 before the reference calls, and then we're printing var 1 after the reference calls. So we'll notice that we have two different values. So let's say I start off with the value of 2. And then the first thing I'm going to do, the value of 2 goes into the add 1 function. 2 plus 1, var 1 will now hold the value of 3. It's then going to make the times 5 call. 3 times 5 is 15. So var 1 after this function call will hold the value of 15. And then in this one, it's going to do squared. So 15 times 15 is 225. So var 1 after the reference call is going to be 225. And that's if it starts at the value of 2. So that's just us walking through it there. So, but let's get some spacing in here, because we don't, it's going to look like everything is printing one after the other with no spaces. So let's at least get some spacing here. New line and new line. So we'll save it, we'll build it again, and now we'll run it. Enter variable, we like 2. So first thing that it is doing, enter the variable, it is saved, assigns the pointer to the variable, and now we're printing out the address of what stores in pointer. So that's this address here, and of course it's in hexadecimal, so that's why it looks all funky like that. Again, hexadecimal is a lowercase a, b, c, d, e, and f plus 0 through 9. So we're seeing a mix of different combinations in here. After we make that print statement right here, the next thing we're doing is we're seeing out the pointer, which is the dereference, so it's actually pointing to its real value. Next thing we're doing is an add, so adding 2 plus 2 is going to return the value of 4, and it just so happens that 2 times 2 is also the value of 4, so these happen to output the same number just by chance. And now we are doing our var 1 before the reference call is the value of 2. With the value of 2, you add 1 to it, that makes it 3. 3 times 5 makes it 15. 15 times 15 makes it 225. var 1 after the reference call is 225 here. Now let's just run it one more time, but I'm going to do a different value. So we did 2 last time. Now let's do 6. So again, this is just the address, and it tells us the value of 6. When we times it, or 6 plus 6 is 12, 6 times 6 is 36, and then when I start with the value of 6, I add 1, that makes it 7. 7 times 5 is 35, and then 35 times 35 is 1,225. So that brings us to the end of our pass by reference, pass by pointer, and pointer introduction. In the next video, we'll be covering fstream, which is input output of files, how to read to files, how to write to files, and that will be the last video that we have for the introduction to programming section. Following that video, we're going to do a quick project, and then we are moving into our second section. So hopefully everyone is understanding this. I'm trying not to go too fast, but I'm also trying not to go so slow that where people get really bored and lose focus. So hopefully it's at a good pace and it's still challenging everyone. If you have any questions, of course, reach out. You guys know how to get a hold of everyone. Have a good day.